Radhe Radhe everyone. Hi, what's up? Just a minute, I'll just pull it up on Discord and then I'll start with it again. And if anyone is currently watching this live, just let me know if you guys can hear me or not. But I think yeah, you guys can hear me right properly. But still, I just need a confirmation from you guys. I think today there was also the sport forces thing, so not sure how many people will be joining though. So before starting, let me ask you guys a very simple question. How many questions did you guys do? Okay, I think I'm audible. I think I'm audible. Okay, I'm properly audible. So let's start with the first problem. Okay, this is a reverse degree of a string. Okay, so the problem states that you're given a string, you have to calculate its reverse degree. The reverse degree is calculated as for each character multiply its position in a reversed alphabet manner, that is a is equal to 26, b is equal to 25 with this position in the string 1 to 1 index. Sum this product all characters in the string. Okay, so it's a very simple thing. Okay, if it's not like that if you can't do it like you're a very noob kind of thing, it's not like that, but yeah, it's a very simple thing. Okay, so let me go with some example. This is Zaza. Okay, so let's take this example. Okay, now see, what we have to do is we have to, for every specific element, we have to find out what is the value that is corresponding to. So uh, let me use a text box. So this Z is 1. Okay, I'm not sure whether you guys can see it properly. Okay, so this the value of Z is 1. The value of A is 26 because it is in the reverse order. The value of Z again is 1, and this value of 20, this is 26. Okay, now this is in the position of 1, this is in the position of 2, uh, third position, fourth position. Okay, so we are going to multiply all of them. So 1 into 1 is 1, 2 into 26 is 52, 1 into 3 is 3, 26 into 4 is 4 is 24, 4 2, and then 104. Okay, now if you add them up, it becomes 4, 5, 7, 8, 9, 10, 0, 1, 5, 6, 6. So 160, right? I think it becomes 160. So let's check it. Yeah, it becomes 160. Okay. Now they have also shown like how to do it. So it's basically very simple. I'll just go with the code directly. It says that int I is equal to 0 to length, and for everything we can find the reverse order by from z if we subtract it, z or z as you may call it. So from that if we subtract it and then add 1, so this 1 is for the fact that like let's say if I'm subtracting something from z, it means that if I'm subtracting z from z, so z will be 0, y will be 1, and so on. But I have to make it at least 1. So this will be 1, this will be 2, right? That is what we have to make it. So that's why we add 1 to it. and then in this position what we are doing is we are just multiplying it with the specific position. Now why do we add 1? To make it 1 indexed, okay, and then we can just add the sum, okay. Any doubt regarding this, you can like write off. I'm not sure how many people are watching this. I don't think much. Yeah, code forces is there, I get it. And one more thing, like if you're watching this and you find that you find that you can't write it up in the live chat, so it's because like I have put on the subscriber only mode for the live chat. So yeah, that's it. Okay, so you can like subscribe my channel and then put on the live chat. Okay, so let's move on to the next problem. It is maximize active section with trade 1. And the second problem of this over here, that is the last problem, that is 2. Okay, so first let's understand the first part. You're given a binary string s of length n, where 1 represents an active session, 0 represents an inactive session. Okay, you can perform at most one trade to maximize the number of active sessions in s. In a trade, you convert a contiguous block of ones that is surrounded by zeros to all zeros. Okay, so it's like if I'm having some ones, okay, and then there are some zeros, this is 0, and then there's some zeros, okay. So which means that this ones are going to be converted into zeros, okay. So there will be 3 zeros. This is what they mean. But we are not going to just stick over there. Second वाले के mind में optimize approach आ ही रहा था. Can you tell us institution also? Second वाला ना वही कर रहा हूँ मैं. वही explain कर रहा हूँ, ठीक है. And anyways, like anyone else, just in case if you're having any doubt and if you are not being able to like write it in the live chat, it's because I have put on subscriber only mode, so you can like, subscribe my channel, and then you will be like given the access to write. Okay, so there you go. The thing is key. So this is the first thing. Okay, so we can convert any contiguous ones into zeros, and we can also convert after that the contiguous zeros into ones if it is surrounded by 1. Which means that if now over here, second now, yeah, I will. Don't need to buy a board. Okay. Now if there are ones and there is 1 1, now I can again convert all of these zeros that I got into 1 1, right? So this is one of the things that we can see straight off. Okay. Now the thing is that you have to understand that whatever we did it in 2 steps. So is there any method to do it in just 1 step? Can we modify it instead of writing it as 2 steps? So the modification will somewhat look like this. If you look at this pattern, this 1 1 1, I'll use a different color. This 1 1 1, it was earlier 1 1 1, it is now also 1 1 1. So it doesn't change. It doesn't change at all. But this 0 0, this becomes 1 1, and this 0 0, it becomes 1 1, right? Now, okay, so this is one of the patterns that you saw. One more thing I haven't mentioned it yet. That is, obviously you have to return the maximum number of active sessions in S after the optimal trade. So treat S as if it is augmented with 1 at both ends. Which means that even if these ones were not present, then also we can make it like this. Okay, because we have to imagine that there is some imaginary 1 over here. I'll use a different color. Black, yeah. There's some imaginary 1 over here. Okay, you have to imagine like that. Now this is a very important thing. What are we converting from I mean, just a minute. Huh? Okay, so you have to understand like what are we converting from 0 to 1, because that is what is going to contribute. That is going to make the state from inactive to active, right? Because 0 is inactive state and 1 is active state. So the pattern is very simple if you know, look at it. Okay, the pattern is nothing but we are going to consider two group of zeros. that are consecutive. Group of zeros consecutive. Okay. The first point consecutive. Okay. Should I write the whole thing? Okay, I'll write the whole thing. Consecutive. Okay. And the second point is group. Okay. Now, what do I mean by group? It means that the total number of zeros over here, you will consider it as one group. Now, let's try to do it using one of the cases, one of the examples that is given. Okay. So, let's say this is a big one. So, I'll take this. Or rather, I'll take this or this. I'll take this. Okay. Now, see, I can convert any two group of zeros to all ones. Okay. So, what is the group of zeros over here? There is a 1, 3, and the other group is 2. So I can convert to consecutive. So I can convert both of them. So I can convert this 5 zeros into 5 ones. And already there were 2 ones present. Okay. So 5 plus 2 is 7. Look at the answer, it is 7. Let's go with this example. A little bit of, I mean, yeah, let's go with this example for you to understand better. Okay. Ab dekho. Now the groups are like 1, 1, 1, right? The first group is having 1, 0. Second group is having 1, 0. And third group is having 1, 0. Which means that either you can convert these two zeros, I mean these two groups, or you can convert these two groups because they have to consecutive. So in either ways it is 2. Okay. So you can have 2 or 2. So you can have 2 zeros converted to 1. And earlier we had 2 zeros, 2 ones already there. So that is 2 plus 2. That is 4. Okay. Now just let me know if you guys are understanding it or not, because I think it went down again. It went down from 5 to 2 again. The watching I meant, but it's okay. Okay. So I'll just explain the whole thing. Okay. It's like you're having vector in zeros. That is going to consider the number of zeros in it. You have 0 is equal to 0, j is equal to 0. So zeros is basically nothing but group of 0. Okay, the group of 0, the groups of 0 rather, or rather the groups of zeros. And 0, this 0 is basically the count of 0. Okay, and this j is just there to like because you know, like I'm making the group of zeros as n, but obviously there won't be n group of zeros. It is not possible. So this is the maximum thing that it can have. So that's the reason I'm doing it. It should be rather n by 2 also works, but yeah, let's make it n. Okay. Now what we are going to do is, if f of I is equal to 0, so it's a 0, 0 plus, so that means I am having a 0. Otherwise, I know that a group of 0 has ended. Okay. Because a group of 0 ends, the first position we encounter a 1. Right? So the first position that we encounter a 1, that is the first position we encounter something which is not a 0. That is 1. It ends, and it means that there was a group of 0 only if the number of zeros before this, it is 0. It is not 0. That means there were some zeros before it. Because it may happen also like this, that there are ones, 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 right? So not always it means that a group of 0 is ending when the 1 is starting. It means that the number of zeros till now, it is 0. Okay? Because over here, it doesn't mean that the group of 0 ends over here. But let's say if there was a 0 over here, then it means that there is a 0, there's a group of 0 over here. So not all 1 means that there is a group of 0. Okay? So that's what I meant actually. So in that case, you can make 0 0, j plus plus is equal to 0, and then you can make the count of 0 as 0, because at that time you are going to encounter a group of 1s, not 0 anymore. Okay. And at the end, if there is some 0, since you know that you have to treat both the ends as 1, like in an imaginary manner, right? So in that case, like you have to find out the thing that, yeah, we have to also count the number of zeros till that. So let's say if there was some ending zeros, so we have we are also going to consider them. Okay, so that's the condition. That's this condition. Okay? And then we are going to find the number of ones, and then we are going to find out the consecutive zeros. Okay, this is zeros I minus 1 plus zeros of I, and the fact that when I add both of them, okay, so it is basically the total number of ones plus the number of consecutive zero groups. Okay, so I am going to add them for all of them, and whichever is going to give me the maximum sum, maximum result, I'm going to consider that. And initially you can consider that answer is equal to 1, that is the number of ones that are already there, you can keep it. Okay, because it is given that it is not always necessary to do it. You may do a trade or you may not do a trade. It's like you have to do at most one trade. So it's not always necessary. So that's the intuition behind it. Okay. So I think Priyansh and Jatan wrote it out. I don't know whether you guys are clear with it or not. Okay, I'll just put it up in case you guys are watching it till now. For this, I think I have to open the discuss, because today I had some stuff to do. Clear? Okay, okay, great, great, great. I don't know how to react to it. Okay, I can't react to thumbs up. Okay, I forgot. I've been using Teams a lot these days. Okay, so screw this. Okay, so first let's understand what the problem is. Minimum cost to divide array into sub-arrays. You're given two integer arrays, nums and cost. Okay, and both of them are of the same size. You have to both of them are of the same size. You have to understand it. Okay, and you're given an integer k. You can divide the nums into some sub-arrays, and the cost of either sub-array will be nums of 0 plus nums of 1 plus nums of dot 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 till r plus k into I plus cost of L plus 1 cost of R. Okay. Now that I see this, now I find some way to solve this again. Okay, so first of all, let's go to the discuss, because I won't be troubling you with the approach that I came up with. Okay, note that I just a minute. Ah, okay. So yeah, note that I represent the order of subarray 1 4 7. So it's basically telling us that it's a one based indexing. You have to return the minimum total cost possible for any valid division. Okay, so you have to find out what is the minimum total cost. I hope the question is clear, right, guys? The question is clear, right? Okay. I doubt you're not a real person, and maybe I know who you are. Okay, so let's understand. Real? Okay, you're real. Okay, that's great. What's your real name, by the way? KHFDDB. Okay. Intuition. The main idea behind the solution is used to. Obviously, it is a DP problem, so I may not have. I have skipped it. So yeah, it is a DP problem. To partition the arrays into possible. Okay, 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 okay. So no, I'm not sure. Like, why do you guys have something like this, like a username like this? Just to change it, man. It doesn't feel like a good live stream. It feels like you're coming on from some fake account, somewhat like that. So the intuition is the main idea. it is a DP problem, so you have to partition them. For each valid division, we need to account for the subarray sum and the corresponding cost. Okay, to efficiently compute the DP recurrence, we take advantage of convex hull trick. What the heck is this? Okay, this is about convex functions. It is a way to find the maximum or minimum value of several convex functions. Ask, I have solved the ACTs that are available, but new question is not getting solved. How to overcome that? It's all about practice. Okay, like I'm not sure in which year are you, or I mean, how many years have you been practicing coding, but it takes time. Just do it patiently and just work on it. Practice, and you crack it. Okay. Even I didn't know about convex functions. Yeah, one convex function means that maxima thing, right? Maxima minima thing, right? First, let me just check it out also. This is, yeah, that is the maxima minima thing. Oh, this is a convex function, sorry. And this is a concave function. Uh-huh. But I don't know about this convex hull thing, hull trick. I don't know about it. Be able to solve it without knowing the. No, 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 no. I was just doing the normal thing. Okay, I'll just show you what my code looks like. This is it, na? See, the code is, my code is, it's a normal DP thing. Okay, I couldn't do it. That's the reason I'm doing it. Okay, I couldn't do it. That's the reason I'm watching this. Because what I did is like I was doing something tricky today. As I went on to the last problem, I was trying to solve it. Okay, and if you look at it, I will have a lot of incorrect submissions on it. Okay, a lot of incorrect submissions because I was very much into this problem. I thought that I can solve it first and then I can come up to the third one, but yeah, I didn't get the time. So yeah. So what is the hull trick? The linear case is known as convex hull trick because maximum as a function of x is a concave up. Similarly, minimum of as a is concave down. Okay, so let's try to understand. Okay, what the heck it is, or let's do one thing. Let's ask the boss. The last one here, last one is segmentary, and the segmentary will be on the zero thing that I was doing. Okay, so it will be on that. F of I of x is lesser than equal to f of j of x. F of I of x. I'm in final year. What would you recommend me right now to increase my rating? Randomly solving questions isn't helping me. See, you know about the DSA concepts, na? Like if you have solved sheet as you told that you have solved sheet, na? I have solved sheet. So if you have solved the sheets and you are getting into it, like, so you have got some practice, and I think like the companies, the interview of the companies, it doesn't matter on most of CP. Okay, it doesn't matter like whether you can solve this or not, because if you look at the rating of these problems, these are hard rated problems. Okay, in a company, in a DSA thing, you just have to crack the medium level things, nothing more than that. Okay, so let's ask ChatGPT to explain convex hull trait. Okay. No, I don't want to know about when to use. Get it? I have to use it. Okay. Our set of linear functions of the form where dash is the slope and dash is the intercept. Okay. Isn't getting shortlisted was a good reading to show. See, you see this resumes, even mine doesn't get shortlisted. Okay. It's like it doesn't get shortlisted sometimes. It's okay. Okay, when adding a new line, we check whether the previous line becomes redundant, wearing the best. Okay, so first let's try to understand what he has done. Okay, I don't think like it's going to help us by knowing what it is. So pre-processing prefix nums represent the sum of first I elements in the nums. Prefix cost represents the sum of the first I elements in cost. Okay, because that is something that you will be needing. Sum of first I elements you have to know about it, and sum of first L elements you have to know about it because you can subtract sum of first R elements minus sum of first L minus 1 element. So you get this, okay? So that's the reason he has pre-computed them because we need that. We need them. Now dynamic programming setup, create a DP array previous initialized with a large value that is long max. That previous of J returns the maximum. Okay. Is the DP array that he's using? He is not using a DP array. Okay, DP array previous. Previous is a DP array. Okay, he is using a previous. Okay, so it is a 1D DP array, okay? That he's storing the all the DP values. So minimum cost to partition the array up to index J. Okay. So it is like till one index I can find out what is the minimum cost that I need to partition it. Now DP transition uses using convex hull trait. So I iterate over the like DQ to maintain candle lines or the convex hull trait. I don't think I'm happy with this actually. This convex hull trick I'm not sure about it. Like how can I say that it's easy to understand? I get it, it's a convex hull trick. Let's check out the Python memorization code, okay? I think the convex hull trick is basically doing nothing but it is making the optimizing the whole thing, na? Okay, it's like if slopes are increasing, new lines may remove old lines. Okay, so we maintain only the useful lines. Okay, so this is it. Okay, structure of line is this, and then I'm having a DQ and return L3 of C minus L1 of C. So if the middle line is redundant, okay. So I have to find out like if the middle line it is not of any use only. Okay, so then I can remove it. Okay. Now I get it. Now I get it. So if the middle line is of no use, you just remove it. So that is the thing. Okay, it's about in the DQ you just removing it. Okay, so that you can get the minimum. Okay. It's not using a convex sulfate, right? Okay, so this is a good one, I guess. I guess this is a good one. So prefix sum for nums and costs, since it is used for every subarray. I have explained till now. Okay, so I am having the prefix of nums and prefix of cost. Okay, now best split, that is something that is going to return, I guess. No, it is returning vector. What the heck is best split though? Okay, it is like basically his. This is basically nothing but -1 into the whole of the length. Okay, that is the best split, and he is using a memoization. Okay, now here the comes the recursion. If index is equal to length of nums, he is returning 0. Okay, that means you have reached the end. And if it is already done, like if it is not already done, so you know what memoization does, it just finds out from the memo table. Okay, and if it's not done, then only if it's done, then it's going to find it from the memo table. Okay, and if it's not done, so now you have to figure it out. That is best split of index. Okay, that is a sub array number, doesn't affect the best split here. Okay, a lot of things are going on above my head, man. I'm getting confused on which one to choose. See, now what we are doing is, okay, I'll move on to the C++ only, okay? Just ignore the hull, convex hull thing. So what I'm doing is I'm from 1 to n, I'm going through it, and then I'm finding for r is equal to m to r is equal to less than equal to n, okay? So for the next element, so we are having a partition, right? DP transition, to maintain the candidate lines or points for the convex hull fit. For every possible ending index r of the subarray, update the current DP state color of r by adding candidate points based on the previous DP state, removing dominated candidates to ensure optimality, using a DQ front to quickly compute the minimal cost for the current state. Okay, the answer will be stored in previous n. So previous n is basically nothing but the DP. Now I'm going to go for the current. I'm using a DQ. We'll understand why he is using a DQ. Okay. Now obviously the R, that is the ending point, it's from M to N, any position from M to N, because we can remove the previous elements from, because if you're just considering that you're going to take that specific element, okay, so it is very much usual that you have to consider so it is very much it's a very much simple thing that you have to use all of them. Okay, and then what you can do is you can find the whichever is the maximum of it and you can keep it. Okay, that is while dq dot size, this is the hull thing. Okay, so we are going to pop from front. If dq of size is greater than equal to 0 equal to 2, that means we can have one element over there. And if dq of dot second minus val into dq of first, this is basically the sum that we are needing for. Okay. Even I was confused, like I, today I did this Leetcode just out of fun, okay, because I didn't want to wake up till late night. I need some rest, so I just did this. Okay, so this is basically the convex hull thing, and if not DQMT, so you know what is the current is going to be. Otherwise, you don't have to worry about the current, okay? And previous is equal to current now, because now whatever the current is, now for the next one, this is going to be the previous, okay? So that is the reason he's updating the previous with current. And what is previous? Previous is basically nothing but and yeah, answer comma previous of n. So it's basically very simple. What I am getting from here is, I'll just explain you, okay, for you better understanding. Let's say I'm having this array. I think Excalibur should start giving this array structure also by default. Or maybe we need, someone of us need to code it out so that we can have it as an extension. Okay, because it is too difficult to make an array like this. Okay, so let's say we are having an array like this. Now, from this position to this position, I have the DP. Okay, now from the next position, okay, what we are doing is, let's look into it. Okay, for the next positions, we are going to find out all the things. Okay, the prefix of cost of j from the previous of j. That is, we are going to find out, like, let's say all of them we did it individually. We made this one group. We made this as one group. This as one group. This as one group. This is one group. This is one group, and then we computed. Okay, or maybe at some position you made both of them as one group. Okay, or at some position you made these two as one group, or at some position you made three as one group. Okay, you don't know about it, but what is the maximum? It is basically nothing but 1, 2, 3, 4, 5. So we have already had 5 groups. And what is the minimum? We can have all of them as a one group. Okay, so considering we have just one group, compute. Considering we have just 5 groups, compute. Computed. Now keep this as this and then start from the next position. Done. Great. Start from the next position. Done. Great. Start from the next position. And doing this, just continue doing it. Okay. And for every specific position, you have to find out what is the value of this last element, because that is what going to matter to us, right, in the DP. And for every specific case, whatever the value of DP of n is, you just going to keep the minimum of it. Okay. What is the value of it is? You have to keep the minimum of it. And that's the answer. Okay. Clear? And just to optimize it, he is using this convex hull thing. I'm not much sure about it, but I think you guys will get it. If you like, I will just go through it. So I'll just go through it. Yeah, I'm not much sure about it, like what is happening over here, but this is what he has done. Okay. So I won't ask you guys should we move on to the next problem or not, because obviously I haven't explained this problem. I've tried explaining this problem, I haven't explained it. So yeah, let's move on to the next problem. Okay, so first let's understand what the next problem is. So if you are rewatching it and if you don't know about it, or if you are just coming now and watching it, don't know about it, so I'll just tell you that just go back to the point where I was explaining the second question. Okay. Oh, sorry, this one. Okay, because this is the advanced version of this. This was state 1, this is state 2. Now herein what happens is that we are going to specify everything is same. Just we are having a query. Okay. Just don't look at my code. We are having a queries. Okay. If you want the submissions, I can show you. So there is a queries which is having the L comma R. Okay. That is the sub array in which now you can perform the operations. Now you can perform the trade only within that specific sub array, not apart from it. Okay. So that is the point where we are going to have a constraint. Okay, so let's. No, I don't want to find this. So if you want to see my solutions, I'll just show you. This is wrong answer. This is TLE. Yeah, this was a TLE. Leave it. We'll just go to the discuss refresh again. Okay. Okay. You see this? Like when I had a very long case, it got a TLE. Okay. So that's the reason. Like I can't have it. Basically, that is what I mean. Now let's go to the discuss. Okay, it shows it makes us main discuss, but we don't want it. Don't you guys think that Unit's code forces? Okay, great. That code had code forces ended by now. I'm not sure. It's 10:15 now. I think it goes till 2 hours. So yeah, I think it's ended. Okay, so let's get into the discuss. How was your code forces? How did it go? ABC. It's all great. There aren't any solution topics here yet. No one has solved it over. No, it's not. It's obviously not like that. No one has given the solution of it. Okay, no one has explained that. That's what basically is. So let's do one thing. Let's go to the home page and try to understand anyone's solution. Because it is segmentary, yeah, it is segmentary. It's getting too hot, man, these days. I'm streaming using a red light, if you can see, like, it's just to keep the temperature low. I could have also used a blue light, but it messes up with the color. Okay, this is what the green does. This is a blue thing, okay, and this messes up with the color. And this is what the actual light looks like. Okay, this is a little bit warmer. This is the warmest. This is okay, right? This looks cool. This much more cooler than that. I think D was too much. Okay, Port Forces. Yeah. No way, man. I will just go through it. Okay, I'll just look into it. Maybe not now, but yeah, sometime I will. Just... How come I get 597 with just two problems being solved? Hmm? How is it possible? Like, are there not much solutions on that? On the second and the fourth problem? That's kind of a good thing for me. Rating's not gonna go that down. You know? What faster? You did you did code forces, na? I'm explaining lead code. I don't get it. Okay, submission. Okay. Faster submission, yeah, I get it. Yeah, obviously that was an easy problem. No, you did it in within the first 10 minutes, and that too also I just messed it up a little bit. So it took me a little bit more time. I could have done it way earlier. Okay, you solved both in 10 minutes. Yeah, that's too long. That's too much, to be honest. Like you should target to solve the first two problems if they're that easy within the first 5 minutes, or rather 7 minutes is good. Well, good enough. Okay. Oh yeah, I will have to use Chat GPT to understand the solution. Because I'm not like I'm too tired to understand what he has done. Okay, to be honest. So what does ChatGPT tell us? The function processes a binary string and answers multiple queries about the maximum number of active session continuous sequences of ones that can be obtained after swapping exactly 1 0 to 1 in a given. It comes with a different logic only. So I'll just explain you what I have a thinking about it. Okay, let's skip this also. Okay, I'm too tired, man. So what we can do is, let's say the fact that we are having some arrays over here. Okay, reasoning mode. I'm not that much of a chat GPT user, I think. Came with name 2D default. No, no, I didn't do C. I didn't do C. I couldn't do C. I was explaining it from discuss, okay. It needed 1D DP and something known as convex. Uh, it was convex hull trick, okay. It was something known as convex hull trick. I have to go through it, but I don't know about it. Okay. Now say that let's say if we are having this array and we can perform the operations. Okay, I think I won't be using. Wow, this is nice. What the heck was that? Excalibur glitch. Okay. Now see, the thing is that what I came up with is that let's say if you're having the constant that you can only change within this subarray. So you know one thing, that the number of ones that is already there, it is going to contribute no matter what. No, no one is going to expect that. It's nothing that much expected thing. Okay. Okay. So let's say if you're having a subarray that over where you can do the thing. Okay. So within this you can already get the, as what I was doing earlier was I was getting the group of zeros, na? I was getting the group of zeros, then again the group of zeros, है ना? So we were just getting the group of zeros. Now what we are going to do is, not only we are going to get the group of zeros, but we can also store the first position where the zero occurs. Okay, I'm talking about my approach though. So we can have the first position where the zero occurs. Now since I know that L is over here and R is over here, so I have to find out the first group that L will encounter. So that is the first group that starts, or rather the first group that ends after L or at L. The first group that ends at L or after L. So this, let's say this is a group, okay. This is a group of zeros and there was a group of zeros over here. So what is the first group that starts after L, that ends after L? It is this, okay. Similarly, if this was a group of zeros, then also this will be considered, right? So this is the first group that we have to consider. Now, if it is like it is starting before L, then we can't consider it. What we are going to do it, we have to modify it. Instead of having this as 3, we can write it as 2. Okay, we can write it as 2 and we are done with it. Right? Great. Works. Good. Well and good enough. Now that we know that it is going to be 2, and similarly we can do the same thing for R also. This is a valid subarray. I mean, this is a valid group. Even this is a valid group. Okay. And if this is a valid group, so we have to remove these things. So if it is 3, we have to make it 1. Okay. And within that, so let's say there's some groups over here. Okay. Now that I have chopped off from both the ends. Okay. So from both the ends, if I've chopped off, so now they look like this, right? Now that I have this group of zeros, now I can compute on that. Now this is where the segmentary comes into play. So using the segmentary, what you can do is you can find out for a specific segment, right? But this is a little bit higher than that. That is, you're going to find out within that specific segment. But if the answer is this plus this, obviously you can compute it out directly. If the answer is this and this, it means that we have to reconsider it. Because we have already used this, but we shouldn't use this part, right? We should have chopped it off, right? So then in that case, we have to reconsider it. So what we can do is, we can get the answer for this part. Okay? We can get the answer for this part, right? And now that we have got the answer for this part, then we can just take into consideration combining these two groups and combining these two groups. Okay? Is it clear? Like I haven't implemented it, but this should be the specific answer. Okay? Is it clear? हाँ या ना? बस बोलो ये. Because this is the main thing, okay, that you have to understand. And anyways, people who are watching it right now, if you haven't subscribed and liked my video and channel, so you can do it. Okay, that's it. So now that, so this black thing you can do using segmentary. Okay, how to do it? Like obviously you don't need to compute everything. You can compute the maximum of consecutive pairs. Okay, you can do it, and then you have to just have to do 2 checkings. Okay, one is this and the other is this. Okay, now that you have done both the checkings and you have got the segmentary, now the most important thing is that you have to just compute it. So what is the time complexity? Big O. Obviously you have used n, right, to pre-compute all of them, even the segmentary also. So let's say it has taken you big O n log n. Okay, plus for every query you have to have for log of n. Okay, because from log of n you're getting this black, and this remaining 2 you can do it in two steps, and that is a constant, right? 2 is a constant basically. So yeah, rather it's going to be like this. To be very much appropriate, it is going to be q log n plus 2q. But obviously you can remove this 2, so it becomes plus q. Now that q log n and q is there, so obviously you can remove this q also, because q log n is better, I mean greater. So now it is q log n log n. Rather, you can also write it as big O of maximum of n comma q log n, right? So using this time complexity, you can compute the whole thing. Okay, I don't want to expand this too much. I'll just quickly go on with the rating of all the problems, and I'll just end it up. Okay, I'll just end it. This is medium, this is hard, this is easy. Easy, medium, hard. The first problem, very easy. Second problem, easy. Third problem was more than medium, D was hard. Or rather, I will just put it in a different manner. I will just put it C and D both as hard. Okay? Because both of them were hard, man. The B can, you can still say that B is easy. Or even if you're not satisfied with B being easy, what I can do is I can put it somewhere over between easy and medium. Okay, but C and D, it was real hard. Okay, so that's it from my side. Thank you guys for watching. That's it. Radhe Radhe.